Hello students, let's discuss the chemical properties of metals. I'm sure that you are already aware of the physical properties of metals. That is, metals are malleable, ductile, they are sonorous, they have lustrous appearance, they are good conductors of heat and electricity, and therefore now we are moving ahead with the chemical properties. So children, what are we going to study in chemical properties? The reactions of metals, how metals react with air, with water, with steam and with acids. So let's proceed with the properties one by one. So first of all, let's discuss about what happens when metals are burnt in air. So what we will do, we have to take a metal sample and then we have to burn it in the presence of air. Children, by burning in presence of air means we are saying that we need to burn in presence of oxygen. Why? Because oxygen is the supporter of combustion. So that's why when we talk about burning metals in air, it means we are talking about burning in presence of oxygen, right? Now for that, what we will do? We will collect the samples of following metals, and those metals are aluminium, copper, iron, lead, magnesium, zinc and sodium. I'm sure all these metals are available in your chemistry lab. If there is any metal which is not available with you guys, that's okay. You can even take another example or another sample of metal, or else you can proceed with only those metals which are available in chemistry lab. Now what we have to do? We have to perform the activity to identify the chemical properties of metals. So the first property that we will be identifying is to observe the reaction of metal with air, that is oxygen. So what we will do in this? We will burn the sample of oxygen and then we will see the color of the product, and hence what we will do? First of all, we will burn the sample over the flame, then we will collect the product sample and cool it down. Then in that case, while performing this activity, we will observe the flame color. Yes, because metals produce lot of beautiful flame coloration. Then we will also look for the appearance of the metal surface and the product surface, followed by we will check the solubility of the product in water. So we will be doing few more follow-up experiments with the burning activity, right? So what we have to do? You have to just burn the sample in flame and see the color of the flame, check the surface of the product and its color. Then at the end you will check the solubility of product in water. So what are the observations that we will observe? We will observe that the product formed is an oxide. Yes, so what is the main observation? That whenever metal is burnt in the presence of air, it will react with oxygen, right? And what will it form? It will form metal oxide, right? So which all metals have you observed? So first is, let's talk about sodium. Sodium and potassium, they are more reactive metals. So do you know that they are always kept immersed in kerosene oil? Why? Because sodium and potassium are so much reactive that if they are exposed to air, they will catch fire. So we have to make sure that we have to put them in kerosene oil. So how will they react with oxygen? Both sodium and potassium, when they react with oxygen, they will definitely form metal oxide. So they will form oxide. So I am writing sodium oxide. Make sure to write the correct valencies. Now let's balance it. I can see there are 2 oxygens on left hand side. So let's multiply 2 here. Now sodium atoms are 4 on right hand side. So let's put 4 here. So what was the observation? The sodium metal reacted violently and catches fire when it is exposed to air, right? So it doesn't need much of burning. It immediately catches fire as soon as it is exposed to air. So the next sample that we can discuss and you have observed is aluminium, right? Aluminium, when reacts with oxygen, it forms Al2O3, the oxide of aluminium is Al2O3 because aluminium valency is 3 plus and oxide is O2 minus. So when you crisscross the valency, you will get Al2O3. Now let's balance this. So I am multiplying 2 here. That way oxygen atoms are 6 on right hand side. So let's make 6 oxygens here and 4 aluminium atoms here. Similarly, when we did the burning of magnesium ribbon, so it reacted with oxygen to form 2MgO. Yes, and let's balance it also. Done. So children, a very important information to be noted. Whenever we burn metal samples, it is advisable that you should always clean the surface with the sandpaper. Yes. Why should we clean it with sandpaper? Because metals like magnesium, they are reactive metals. So when they are exposed to air, they gradually react with air or the atmosphere oxygen and forms a layer of oxide on it. So as soon as it forms a layer of oxide, and if you will burn it, it will not burn. So what we have to do? We have to clean the surface of the metal, mainly magnesium, aluminium, lead, because there is a layer of oxide. So we need to remove that layer of oxide before burning the sample. Now in case of magnesium oxide, there is a beautiful white dazzling flame appears, right? Now when we talk about the next metal, let's say iron. So when iron reacts with oxygen, what it will form? Definitely it will form oxide, and that is Fe2O3. And what is the color of Fe2O3? Reddish brown. The reaction is not balanced. We always need to write a balanced equation. It is done. Now when we talk about next metal, we have copper. How copper reacts with oxygen? So when we burn the sample of copper, it also produces copper oxide, the metal oxide. Let's balance it. And this is black in color. Then let's talk about lead. When lead is heated or burnt in presence of oxygen, it forms lead oxide. It is yellow in color, right? So let's balance it. Done. And similarly, when zinc reacts with oxygen, it forms zinc oxide. Let's balance it. Done. Children, zinc oxide is white in color, but on heating continuously, it turns yellowish in color. So these are the oxides formation. So my question to you is, what do you think? What is the type of reaction here? So children, the type of reaction here is combination. Why children? Why is it a combination reaction? Because as you can see, we are combining two reactants and forming a single product. See, in all the cases we are getting single product, right? So whenever we get a single product, what is the type of reaction? It is definitely a combination reaction, right? And when you will observe the metal samples, how they are burning, you will find that actually they are reacting on the basis of their reactivity. What do I mean by this? That sodium, which is a highly reactive metal, it will react violently with oxygen and catch fire. Then when we talk about the moderately reactive metals like aluminium, magnesium, iron, they do react, but comparison to sodium and potassium, they react little less vigorously with oxygen, and there is the oxide deposition. Then when we talk about the lower reactivity or the lesser reactive metals, you will observe that they will react slowly with oxygen. And what do you think? What about silver, gold? Do silver and gold react? No. You know, silver and gold, they do not react with the oxygen at all. So that's why we can say that the reactivity series can be verified by burning with oxygen. Yes. Now still we cannot verify the reactivity of these oxides, which are moderately reactive oxides. For that we have to do more activities in order to classify the reactivity of aluminium, magnesium and iron, that which one is more reactive and which one is less, because in all the cases, all these cases, they are moderately reactive. So we are unable to identify just on one basis or one grounds that how do they react with oxygen? So we need to have more activities in order to justify that which one is more reactive out of aluminium, magnesium and iron, mainly in case of moderately reactive metals. But yes, most reactive metals, they react immediately with oxygen and catch fire. The least reactive metals, they don't react at all with the oxygen, and even copper, it reacts slowly with oxygen, being lesser reactive than hydrogen. Still, we cannot identify the reactivity order of the moderately reactive metals. For that, we will do more activities, right? Now, let's jot down all the observations that we have seen in the video, that we have discussed or observed in the activity in the tabular form. So, now let's discuss what were the observations. So, we have metal sample. So, first metal sample we have is aluminium. So, what we will talk about? Metal sample, the product formed on burning, that we have already written in the reactions, right? Then the color of the product, the flame coloration, then the solubility in water. Whose solubility? The solubility of product in the water, right? So, the first sample we have is aluminium. Aluminium on burning forms aluminium oxide, and what is the formula? Al2O3. So, what is the color of product? The color of product, children, is white. And what is the flame color? So, when aluminium is burnt, the color of the flame is silver white. It is silver white. And what about the solubility in water? Children, Al2O3 is insoluble in water. It does not dissolve in water. So, I am writing here insoluble. Now, the next is copper. Copper on burning forms CuO, copper oxide, and it is black in color. On burning, it produces bluish green flame. So, let us write here, it produces bluish green flame, and even copper oxide is insoluble in water. Now, when we talk about the next one we have, children, is iron. Iron forms Fe2O3, ferric oxide, which is reddish brown in color. Have you seen rust? Yes, rust is Fe2O3, right? So, it is reddish brown in color. And what about the flame coloration? Children, iron produces orange brown flame. Yes, a beautiful orange brown flame is produced, and iron oxide is also insoluble in water. So, you will notice that most of the oxides are insoluble in water. Now, let us proceed with the other samples. So, if we have lead, lead forms lead oxide on heating or burning, which is yellow in color. The flame is blue in color, or sometimes we will see it is whitish in color, and then it is also insoluble in water. Now, when we talk about the next sample is magnesium. It forms MgO, metal oxide, which is magnesium oxide. Now, magnesium oxide, children, it is white in color. And what about the color of the flame? The flame coloration is a beautiful white dazzling flame. Yes, white dazzling flame appears. And children, very important point, magnesium oxide is soluble in water. Right, it is very much soluble in water. It forms magnesium hydroxide very easily. Then what about zinc? On heating or burning zinc, we will get zinc oxide, ZnO. And it is white in color, but gradually it will turn yellow on continuous heating. Children, zinc oxide produces colorless flame. Sometimes you will see it is little greenish, but usually it is a colorless flame, and it is also insoluble in water. Now, when we talk about the last sample, which is sodium, it produces sodium oxide, Na2O. And children, sodium oxide is white in color. Then, what is the color of the flame? Children, sodium produces beautiful golden yellow flame. Golden yellow flame. And sodium, when it produces sodium hydroxide, is highly soluble in water. Sodium oxide is highly soluble. Why? Because as soon as it is dissolved in water, it forms sodium hydroxide, NaOH. Yes, that's why it is very much soluble in water. So, you will observe that mostly metal oxides are insoluble in water, but there are few exceptions like magnesium oxide, sodium oxide, they are soluble in water. Similarly, potassium oxide, calcium oxide, they are also soluble in water. So, when we talk more about this activity, can we conclude that all metals react with oxygen to form metal oxides? Yes, so in generalized term, can I say this? Metals when react with oxygen, what do they produce? What is the product formed? They produce metal oxide. Yes. And the reactivity towards oxygen can depict the reactivity order of various metals. Yes, did we discuss this already while writing the reactions? That more reactive metal like sodium, it catches fire immediately as exposed to air. So, definitely we can say that it is a more reactive metal because it reacts immediately with oxygen. So, what is the decreasing order of reactivity of metals towards oxygen among our samples that we have taken? So, first of all, can I say the most one is sodium? Yes, it catches fire immediately. Then after that we have magnesium, then we have aluminium, then we have zinc, iron, lead and copper, right? Did we take 7 samples? 1, 2, 3, 4, 5, 6, 7. Yes, so we have arranged all of them on the basis of their reactivity. So children, I hope you have understood the activity. Thank you.